So there are two other ways that information might be given to you in a problem. And these build on the same ideas of everything else. It's just another way of introducing information. So one way is that instead of giving you like 1.0 molarity here and 2.0 molarity here, it might just say that 50% remains after a certain period of time. And then might ask like how much was there initially. Well, here's the deal. Is for initial, it's always 100%. Initial is always 100%. So as long as it says percent remains, then that's what the top number is. So it's like saying this. We have 50 over 100. That's actually the same thing as these numbers right here. It's just explaining that it's another way of saying it. Now, it could also be phrased like this, and I'm going to change the number, that 40% decayed. So if 40% decays, the amount that remains is 60%. So in that case, when you're filling it in, you would do 60 over 100. So you have to watch the phrasing on this. If it says remains to begin with, you're great. If it doesn't, then you need to figure out how much remains by subtracting the number from 100. So that's one other way of writing that. And then this is the other way. So you know that these brackets mean molarity. So I've started off the molarity. So this is not new. This is just the molarity of A of t, there's A of t, over the molarity of A of 0. Now, since this is a one reactant system, like the reaction and what's in the reaction, like the amount of moles of A is in the solution, then what we say is, well, the total liters of the solution hasn't changed. And so the liters of the solution could cancel out because they're both in the same solution. Yeah, they're turning into product, but they're both in the same solution. Then the next thing that you can say is that, well, if I go from moles of A of t to grams of A of t using the molar mass, and I haven't defined it, but let's say the molar mass is like 40 grams in 1 mole, from the periodic chart. So let's say 40 grams in 1 mole, and this molar mass is 40 grams in 1 mole. I should give these numbers also. So like that's 2 to 1, 1 to 2. So you'll notice what happens is that this unit right here will cancel with this unit. And then this unit will cancel with this unit. So ultimately, another way to write this equation is the natural log of the mass of A at a time over the mass of A at 0 is equal to negative KT. And again, the reason you could do that is because A was the only reactant, and so in both scenarios, initially and later on, it always had the same molar mass. And then it was also because there was only the one reactant and the liters of solution isn't changing, and so you can cancel out the liters of solution. So those are two other ways that you'll see problems in the homework.